Hi guys, we're going to finish off this unit with lesson 6. We're going to be doing parallel and perpendicular lines today. So let me go ahead and start off with, just going to skip this first section here and go right to investigating parallel lines. So on the grid, show the image of line segment AB after the following transformations. And transformations is just shifting the line segment around. So here we have AB, a translation of 4 units to the right and 1 unit down. Okay, well, let's go ahead and do that. So I'm going to pick the point A and I'm going to shift it over 4 units to the right. So 1, 2, 3, 4. Okay, there's the new A. Actually, take that back, and I have to do one down. So there's 4 to the right, and then it also says 1 unit down, so right there. So there's the A. And I have to do the same thing to B. So 1, 2, 3, 4, and 1 unit down, B. And then I'm going to connect those dots to move my line segment over. And if I keep doing this again, the translation of 3 units to the left and 6 up. So 3 units to the left would be 1, 2, 3, and 6 up. 1, 2, 3, 4, 5, 6. So there's the new A. And do the same thing for B here. So I have 1, 2, 3, and 6 units up. 1, 2, 3, 4, 5, 6. Okay, there's the new B. I guess I can't really call it AB anymore because that's the original AB. So I should either call this one A1 or A2, B2, and then A3, B3, or you can use completely new letters like C, D, and EF. It doesn't really matter. Okay, I'm going to skip this last one. And then it says calculate the slope of each line segment. Well, I'm pretty sure we can all figure out that the slope is going to be the same for all of these lines. So let me go ahead and do the slope here. I'm just going to do the shortcut method of counting because I can do that fairly quickly here. I know my slope, so I'm going to write M. Oh, by the way, I forgot to mention that M is our letter that we use to represent slope. I know it's not really intuitive. You're thinking we should probably use S for slope, but M equals slope. And then remember that slope is rise over run. And the rise here would be 1, 2, 3. And then the run would be 1, 2, 3, 4, 5, 6. And again, I have to make sure that I get my direction right. That's negative. And I'm going to go ahead and simplify that to 1 over 2. And again, that is the slope. Now, if we calculated the slope for the other 2 line segments, we would also find that it's going to be negative 1/2. So the conclusion here, it says here the 4 line segments, and 3 in our case because we didn't do all 4, are parallel. Make a conjecture about the slopes of parallel lines. Well, that is just like what's the point here? Well, the point is, or I should say a rule, is that parallel lines have the same slope. Okay, so parallel lines have the same slope. All right. Okay, that one's pretty straightforward. That makes sense intuitively, obviously. But perpendicular lines are a little bit different. Remember what perpendicular means. Perpendicular is when something is at a right angle to something else. A line segment is at a right angle, or a street can be at a right angle. So if we have an intersection, and there's one street and there's another street, well, those streets are perpendicular to each other. Okay, or the x and y axis are perpendicular to each other. So let's go ahead and do this little investigation here. On the grid, plot A is 5, 2. So 1, 5, 2. There's A. And draw the line joining the point to the origin. Well, there's the origin here. So let me go ahead and connect those dots there. Just going to zoom in a little bit. Okay. Okay, so rotate the line through an angle of 90 degrees clockwise about the origin O to show the image on the grid. So if we were to rotate this 90 degrees here, where would I end up? Okay, to make this rotation, you have to sort of use a little bit of visualization here. But really, if I rotated this whole thing 90 degrees this way, then basically the x-axis would become the y-axis. So this would go over here. This would come up here, and eventually you can do a full 360. But if you're just to do a 90-degree turn, this x here would just go down here. So that's a 90-degree rotation clockwise. Well, if everything rotated 90 degrees clockwise, see if you can go ahead and draw this line segment. Where would it be if I rotated this 90 degrees? Well, if I rotate this 90 degrees, it would end up right over here, and point A would be 90 degrees. And the way you know it's 90 degrees is if you have, we all know that a 90-degree angle is a right angle, therefore these two, the angle here must be 90 degrees, and these two lines must be perpendicular because, as we said before, perpendicular lines are all at right angles to each other. Okay, so what are we doing here? So what are we trying to find out? Okay, we're trying to find out the relationship between the two slopes. So now it says find the slopes of the two lines. Okay, so the slope of line 1, and let's label this line 1 and line 2. So the slope of line 1, and I'm going to go ahead and go M, and I'm going to put a 1 there, so to designate slope of line 1, equals, well, I can quickly see this one, that it's going to be, if I do my rise over run, it's going to be 2 over 5, positive. Okay, now line 2, so M2, the slope of line 2, which is this one down here, well, I know it's going to have a negative slope because it's falling as I'm going from left to right. But let's see if we can come up with some sort of relationship. First of all, what is the slope? Well, it's falling 5, or rising 5 in the opposite direction, and the run would be 2. Okay, so I am starting to see some relationships here between perpendicular lines. There's 1 and there's 2. So the question is, okay, so let's make a conclusion here, and our conclusion is going to be, it's going to be this. First of all, the relationship here is fairly obvious. What was once in the numerator goes into the denominator, and what was in the denominator goes into the numerator, and the sign went from a positive to a negative. So the conclusion here, and you can write that down here in your conjecture, is that the slope of perpendicular lines are they have a reciprocal relationship and the opposite sign. For example, let me do a whole bunch here. So if the slope is 3 over 2, if M1 is 3 over 2, M2 is going to be negative 2 over 3. So what's happening here is you take the negative reciprocal. Same thing, if I have negative 4 over 5, the negative reciprocal of that would be 5 over 4. All right, so the interesting thing is when you multiply the two slopes out, you should get negative 1. Okay, and these cancel out, this cancels out, you're left with negative 1. 2 over 5, if I multiply these together, 2 times 5 is 10, 5 times 2 is 10, negative 1. Here also, if I multiply these together, negative 1. So the slopes of perpendicular lines multiply to negative 1. Okay, and that is written here as the conclusion for both parallel lines and perpendicular lines. So the product of the slope is negative 1. Okay, let me do one more, or a couple quick examples here. Consider the line segment AC with a slope of 3 over 4. Write the slope of a line segment GH, which is parallel. Well, pretty straightforward. Parallel lines have the same slope, so it would be 3 over 4. Write the slope of line segment BF, which is perpendicular to AC. It would be negative 4 over 3. Determine the lines, if the lines are parallel or perpendicular or neither. Well, 1 over 4, again, I can simplify that to 1 over 4. So the lines are parallel. I'll write it like this, parallel. And here I have 5 over 7. And here I'm going to, again, just reduce this to 7 over 5. Oh, look at this. This is where you might get confused. It looks like they're perpendicular, but they're not, because they're both positive, and that cannot happen. So they're not perpendicular. They're actually neither, okay, for that one. All right, and if you were to graph this, 7 over 5 would look like this. 7 over 5 would look something like that. And 5 over 7 would look something like this. So they're not quite perpendicular. All right. If P is the 0.47, Q is the 0.6 negative 2, find the slope of the line segment. Okay. Find the slope of a line segment that is parallel to the segment PQ. Well, PQ, so I'm going to go like this, M, PQ. First I need to find the slope, and I'm going to go y2 minus y1 over x2 minus x1. Do that fairly quickly. I'm going to make this one the 1 and this one the 2. So I got 7 minus negative 2, which is 7 plus 2, over 4 minus 6, which is 4 minus 6. So I'm going to get 9 over negative 2. There's my slope of PQ. Parallel to that would also be negative 9 over 2. Perpendicular, on the other hand, would just be 2 over 9 and positive 2 over 9. Okay, so there we go. All right, let me keep going here. So the triangle LMN has coordinates. Let me always do a diagram just so you don't mess things up here. Negative 4, 2. So negative 4, 2. I'm going to eyeball it here. So that's L. Negative 4, comma 2. M is negative 2 and 7. So I'll eyeball it up here. M equals negative 2, comma 7. And N equals 1, comma 0, which is there. N 1, comma 0. Okay, and I'm going to connect these because it's a triangle. And what we're trying to figure out, use the slopes to show that the triangle is a right angle at L. So we're trying to prove that this here, where did you go here? There it is a right angle. So quickly, I can just quickly get the slopes here of ML. So the slope of ML would be, I'm going to make the M2 and the L1. So I'm going to go 7 minus 2 over negative 2 minus 4, so plus 4. So that would be 5 over 2. So if this is indeed a right angle triangle here, these two lines should be perpendicular. I'm going to put a question mark here because I'm still not sure if that's the case. So I need now the slope of M and L. NL. So the slope of NL, which is this one and this one, is going to be 0 minus 2 over 1 minus negative 4, so plus 4, negative 2 over 5. And bingo, look at that. These two slopes are the reciprocals of each other, and they're the opposite sign. Okay, where did this go? There it is. All right, last question. This is sort of the hardest question, so make sure you watch, stay with the video here. I know this video is getting a little bit long here, but this is an important question that asks you to think a little bit outside the box here. So two lines have slopes, negative 3 over 4 and k over 5. Well, that k is going to be a pain in the butt here. We want to find the value of k if the lines are parallel. If the lines are parallel, that means they have the same slope. Well, if they have the same slope, well, I'm just going to make their slopes equal. Okay, so there's only one number that would fit for k to make those numbers equal. I'm just going to solve for k. So multiply both sides by 5, and I'm going to get negative 15 over 4. And there you go. That's your answer there. K equals negative 15 over 4. And if I substitute that in for k, let me just go ahead and instead of k, now I have negative 15 over 4. And if you go ahead and simplify that, you will see that those two slopes will be the same, because this side is going to turn into negative 15 over 20, because the 5 and the 4 multiply. That's over 1 there. And that's basically equivalent fractions. Negative 3 over 4 is the same as negative 15 over 20. Okay, perpendicular lines, well, what do we know about them? We know that their product is equal to negative 1. So if I multiply negative 3 over 4 times k over 5, it should equal to negative 1. Well, this one's a little bit easier, so I got negative 3k on top, 20 on the bottom equals negative 1. I'm just going to get rid of those negatives, turn them into positives. And 3k equals 20. K equals 20 over 3. All right, there we go. So this wraps up Unit 6. We're going to use what we know about slopes and line segments to move on into our next unit, where we finally get into equations of line segments. So thanks for watching, and see you next time.